Okay, let's look at example 3. In example 3, we're going to identify linear functions using equations. So as we discussed earlier in our definition, linear functions must be written in the form of y equals mx plus b. Where m and b must be constants. So let's take a look at some examples. In these problems, y equals 3.8. Now this has an x, you just don't see it. What the coefficient of the x term is in this example is 0. So I could rewrite this as y equals 0x plus 3.8. So can this equation be written in the form of y equals mx plus b? The answer is yes. And since that's true, this is a linear function. This one has a square root on the x. Now, in order to get rid of the square root, you'd have to multiply both sides of the equation by another square root, right? We'd have to square both sides. If I did that, I would end up with a y squared equals x. So there's no actual possible way to get y alone and to write this in the form of y equals mx plus b, because this is the square root of x and we can't get rid of that square root symbol. So this cannot be written, so not a linear function. If we look at this one, this has an exponent of x. There's no possible way to get this x by itself. So because you're raising it to the power of x, there's no way to bring this down to be the base. So this cannot be written in the form of y equals mx plus b. So no, not a linear function. In this example, if I were to distribute my 6, I would end up with y equals 6x minus 6. Is this in the form of y equals mx plus b, where m and b are constants? The answer is yes. So this is a linear function. And in this problem, if I solve this for y, I add y to both sides, I'll end up getting y equals x squared. Again, there's no way to get rid of this square unless I square root, but then y is being square rooted. So in this case, this cannot be written in the form of y equals mx plus b. So this is no, not a function, not a linear function. And there's one more problem, which I must have missed, I'm sorry. That problem is y equals 2 over x. So again, even if I multiply both sides by x, I'd get xy here. Right? X over 1. Then I would end up getting xy equals 2, but then I'd have to multiply by the reciprocal of y in order to move y over. So in this problem, again, my y is now in the denominator. And in order to have the y isolated, it has to be in this form. So since this cannot be written, y equals 2 over x is not, is not a linear function. So that concludes our examples for tonight's work. Please complete monitoring progress problems 1 through 7 in the document attached.